Okay. Okay. In our last lecture, we studied about the matrices, and we talk about that the horizontal or the vertical array, the combination of the horizontal or the vertical uh, array, it is known as the matrices. So we talk about different kind of matrices, like for example, this is what you say, that this is a kind of the square matrix. And what else we can call this matrix? Can anyone please tell me what else it could be? What else could it be? Any one of you? Anyone please can tell me what it could be? It could be a diagonal matrix, correct? It could be a diagonal. What else? Square matrix. What else? Symmetric, okay. What else? Scalar. Okay. In scalar matrix, the diagonals should be same, right? So this could be like the diagonal. In a diagonal matrix, all the elements except the principal diagonal are zero. And in square matrix, it is a 2 by 2 matrix. Symmetric matrix, why symmetric matrix? For example, if it is A, then A transpose should be equals to A, then it is called symmetric matrix, right? It is called the symmetric matrix. Okay, so the thing is, it is called symmetric matrix. And then we talk about the various multiplication, division, and various different rules of the matrices and system of linear equations as well. And in our last thing, we talk about the solving the equations, solving equation by matrix method. Okay, so we're gonna have one more practice example, and then after this one, we're gonna move to R Studio, and we will try to solve those equations by using the R method, using the R. Okay, so let's say this is, let's say, example. Let's say example 1 for today. Okay, in this example, they say that solve the following equation. The following equation. What are the equations? X plus y plus z is equals to 1. And second is x plus 2y plus 3z. And finally is equal to 6. And finally we have the last one, x plus 3y plus 4z is equals to 6. Right? We have this system of linear equation. So what is the first step? In first step, we're gonna make the matrix of this system of linear equation. So we always say Ax is equals to B and x is equal to A inverse B, right? So in here, what is my X matrix? My X matrix is X, Y, and Z is equals to A inverse. Okay, so in here, what is A? Sorry. Okay, for example, this is X. What is our A? A is equals to 1 XYZ 1 1 1 2 3 1 3 4, and finally we have B. B is equals to 1 6 6, right? We have this example. So let's try to find the A determinant. Can anyone please find the A determinant? Determinant of A. Because how are we gonna find the adjoint of A? Because A inverse is equals to adjoint of A divided by determinant of A, right? So first we need the what you can say determinant of A, and we want to check if determinant of A is not equal to 0, then what we can say that A inverse is possible, right? So please try to find the determinant and let me know what is the A inverse. Sorry, determinant of A. Please everyone try to solve it and then let me know. Please everyone try to solve it and let me know the answer. I will also solve it. It equals to 1 1 1 1 2 3 1 2 3 1 3 4. I'm I'm gonna use this and this one. Okay, and that's equals to 1 into this minus this. Okay, so 1 into 8 minus 9. This is should be plus, and then minus 1 into this one is 4 minus 3 plus minus and then plus again plus this one 3 minus 2. So our answer is 8 minus 9 is equals to minus 1 is plus 1 and minus 1 plus minus 1, right? So we can say that minus 1 minus 1 plus minus plus minus, no, it starts from minus 1 minus 1, and it should be, sorry, plus 1. It should just cancel here, minus 1. So our A determinant is not equals to minus 1, is not equal to 0. So A inverse is possible. Now in our next step, what we're gonna find? We're gonna find the adjoint of A. So as I told you, what is the adjoint of A? So take the cofactors. Adjoint of A will be equals to the cofactor Cij and transpose, right? So let's try to find our Cij. So for example, let's say cofactors, we call it the minors. Let's call it the minors. Let's call it the minors. So okay, so for example, A11 is equals to determinant 2, 3, 3, 4, right? And A12 is equals to 1, 3, 4, sorry, 1, 4. Let me write matrix A in here, so it will be easy for everyone. It is 1, 1, 1. It is equals to 1, 2, 3. It is equal to 1, 3, 4. Okay, so we have this one is equals to this one, and then this one and this one, 4, 3, 1, 1, A1, to some column. Okay, A1, 3 is equals to 1, 2, 1, 3, right? So this is plus, this is minus, this is plus. Okay, so please calculate the values. Meanwhile, I will write in here. So the next is A second row first column. It will be equals to, it will be equals to 1, 1, 3, and 4. 1, 1, 3, and 4. And then we will have 8, 2, 2 is equals to 1, 1, 1, 4. And finally, A2, 3 is equals to 1, 1, 1, 3. So plus, minus, plus. So there is another thing how to we can take the sign. So just add like minus 1 raised to power 2 plus 1. Minus 1 raised to power 2 plus 2. Minus 1 raised to power 2 plus 3. Okay, and then at the last one, it will be equals to A31 is equals to determinant of 1, 1, 2, 3. And A 3, 2 is equals to 1, 1, 1, 3. And finally, A 3, 3 is equals to 1, 1, 1, 2. Okay, again, sign will be -1 raised to power 3 plus 1. -1 raised to power 3 plus 2. -1 raised to power 3 plus 3. Okay, is it clear? A12. A12 is equals to 1314. 13. So this one and this one is gone. So 1, 2, 1, 1. Okay, so okay, in here it's gone. This one and this one 1, 3, 1, 4. 1, 3, 1, 4. Okay, so it is this one. So please calculate this one. So please tell me the A11. What is the value in here? What's the value in here? -1. What is value of A12? -1. What is value of A13? What is value of A13? A13 is 1. Okay, A21. A21 is equals to -1. And A22, 3. And A23, -2. A31, 1. And A23, -2. And finally, we will have A33 is equals to 1. Right? So now we have a matrix, and I will just try to write in here. So okay, so we have the cofactors already. So we can write it like in this way: -1, -1, 1. And then -1, 3, -2. And finally 1, -2, 1. Okay, and we have to take its transpose. Okay, so transpose will be equals to, we have to take its transpose: -1, -1, 1, -1, 3, -2, and 1, -2, 1. Okay, so this is our matrix. Oh, it looked like symmetric matrix, right? It looked like a symmetric matrix because its transpose is equal to it. So now we already have adjoint of A. This is adjoint of A. So if we have adjoint of A, then how we will find the A inverse? A inverse will be equals to adjoint of A divided by determinant of A multiplied by, sorry, first A, sorry, this one is, so A inverse is equals to adjoint of A divided by determinant of A. Okay, so how we can find the A inverse? A inverse will be equals to 1 minus 1, 1 minus 1, 3 and 2, 1 minus 2 and 4. It is equals divided by determinant of A. Okay, so what was the determinant of A? Determinant of A was minus 1. So the only thing happened, the signs it will change. So it is equal to 1, sorry, minus 1, 1, minus 1. It is equals to 1, minus 3, minus 2. And it will be equals to minus 1, 2, minus 1. Right, this is A inverse. So we talk about X is equals to, sorry, X is equals to A inverse into B, right? So A inverse, we have A inverse in here, minus 1, 1, 1, minus 3, minus 2, and minus 1, 2, minus 1, multiplied by P. What was the value of P? 1, 6, 6. Okay, so let's multiply this one. So you know the rule of multiplication, this multiplied by this one. So first of all, we have to see what is the order or the rank of this matrix. This is 3 by 3 and this is equals to a number of rows 3 by 1. So it means both are the rows of the rows of column B or second column is equals to columns of the first matrix. So it is, we can multiply it. So the answer, it will be a 3 rows and 1 column. So answer will be a 3 rows and 1 column, right? So let's try to multiply. Minus 1 into this one, plus this into this one, plus this into this one. So minus 1 multiplied by this, minus 1 this and this one. You guys got it? So minus 1 multiplied by 1, it will be equals to minus 1, right? Then this multiplied by 6 plus 6, and then this multiplied by, sorry, 6, it will be equals to minus 6, right? So similarly in other, the second one, it will be equals to 1 minus 18 plus 12, and lastly it will be equal to minus 1 plus 12 plus, oh sorry, minus 6. So your final answer will be equals to 1 minus 5 and 5, right? So X was equals to X, Y and Z, which is equals to now 1 minus 5 and 5. So X is equals to 1, Y is equal to minus 5 and Z is equals to 5. This is your solution. Okay, is it clear to everyone? Is it clear to everyone? You have any question, please let me know. Hmm, -1. Wait, let me check. Yeah, it should be -1. Let me check again. Wait, our A11 was -1, and then we make the transpose, correct? In here, okay, we it was 1 in here. Sorry. It was -1 in here. It's supposed to be -1 here, and then it will be plus in here, and then it will be plus in here, and this one will be plus as well, and then it will be equals to 1. Okay, now it is fine. So this is your solution. Okay, so let's move our next topic for today. Okay, so there are elementary operations or transformation on a matrix. Elementary Okay, for example, we can say that if we interchange any two rows of a column. Okay, so for example, A is equals to we will use this example again. 1 1 1 1 2 3 1 3 4, and there is another this one B is equals to, let's change the columns, interchange the column. 1 2 3 1 1 1 1 3 4. Can you find the determinant of A, determinant of B? Okay, please calculate and tell me, is the answer same? Is the answer same? Can anyone tell me? Find the determinant. -1 and 1. Okay, again, tell me, it is -1 or 1. It should be, it should not be same. It should be same. It's same. Again, It is -1 for this one, and it is correct. 1 and -1. Is it correct? Okay, determinant of A is -1 and B is equals to. Okay, so the rule is that if you change the two rows after changing the two rows, your determinant it will become negative. For example, for A it was 1, for B it was for A it was -1, for B it was 1. So if you change any two columns, so we can say that determinant of A is equals to minus determinant of B. You can change the rows. So these are called elementary operations, right? So we will write an element operation with equals to this sign. So we can say that I applied column 1, interchange of column 1 with column 2. I changed it in here. So after changing it, this thing happened. So if you change again, if I change in here, let's see, I change C1 with C3. If I change this one, you will see the answer, the determinant will be the same, but the magnet with different sign. Okay, let's say there will be another column which I write C. So I will change this one. So it will be 1, 3, 4, 1, 1, 1, 1, 2, 3. Now, if you take its determinant, so the answer will be 1. Oh, sorry, -1 again. Okay. So determinant of B is equals to 1. So it was -1 and is equal to -1. Both are 1 is equals to 1. So this is the elementary operations in this one. So always remember, when you change only one time any rows or any column, we can also interchange the rows or any column. So when we interchange the rows, it is called row operation. When we change the column, this is called column operation. Okay, so first thing is you can change the rows or columns. Number two, you can multiply a row or column with a scalar. Scalar mean like non-zero element, and add or subtract from other columns, other rows or columns. What does it mean? For example, you can do it like if A is equals to 2, 6, 6, 2, 8, 6, and 266, 286, and 268 again, 268. If you have this one, you can make a row operation. Like for example, you say that I made operation 2 R1 minus R2 is equals to let's say you make it like operation, it like you made this operation. So what did you do? You multiplied by r1, you multiplied row 1 with 2. If you multiply row 1 with 2, it will be equals to, let's say it will be equals to 4, 12 and 6 and minus r2, and now minus r2, 2, 8, 6. Subtract it. Answer will be equals to 2, 4 and 0. So you can write it 2, 4, 0, 2, 8, 6, 2, 6, 8. Right? So this is called the row operation. You can interchange two rows, or you can multiply any number with any row and subtract or add it into the other rows. This is one of the interchanging thing as well. Okay, so this is the second one, and the last one is okay, and the last one is 3. Just multiply our row or vector or column with a scalar value. Scalar means non-zero. You can multiply this thing k, let's say calls k, and k should not be equals to 0. Okay, these three things you can do to find the inverse of the matrix as well. So we're gonna use some method to find. Instead of using the matrix method, we're gonna use another method which we call it Gauss-Jordan method. Gauss-Jordan method to find the A inverse. So to find the A inverse, it is easy, but you have to just clarify these three operations that I mentioned it. Okay, so the rule is really simple. I think we have already studied this one in our school, in our college, in the basic classes of your maths. Okay, wait, let me write. Okay, in example they say we have a matrix with 2, 6, 6, 2, 8, 6 and 2, 6, 8. Find A inverse by Gauss-Jordan method. So the first rule is that you will write matrix A and the identity matrix together. So you will say 2, 6, 6, 2, 8, 6, 2, 6, 8. Right? And then what you're gonna do, you're gonna make a like this slash and write the one identity matrix 0, 1, 0 and 0, 0, 1. Now what is your agenda? In here, your agenda will be you have to make this portion, you have to make this portion, sorry, um, where is, okay, so you have to, oh, okay, okay. So this portion of the matrix, you have to convert this portion of the matrix into identity matrix. Sorry. Okay. So this portion will be identity matrix by using 3 row or column operations. Remember, we talk about 3 operation. What is the 3 operation? You can in first was interchange, second was multiply with k or any scalar, and then third multiply with k and add or subtract with other rows or columns. Okay, so this gonna be our operation in here. So let's, I will do the first move, like, then let's say how you will think. Okay, so my agenda is I have to make it 1. This is 1, this should be 1, and this should be 0, this should be 0, this should be 0, this should be 0, and this should be 0. So now we can do any things. We can do like all the 3 things. So my first move, I will write it, my operation will be R2, interchange R2 with how can I say, on R2 with R1, and R3 will be equals to, okay, so R2 will be equals, operation on R2 will be this one, and on R3 it will be equals to R3 minus R1. Just do this one. Okay, let's do this one. In first, R2 will be equal to, just change R2 and R1. What is my R2? This is R1, this is R2, and this is R3. Okay, so I put the operation. So it is on R2 and R3. So R1 will be same. It will be equal to 2, 6, 6, and 1, 0, 0. So R2 is interchanged with the R1. Okay. Oh my God. So it will be equals to 6, 6, 0, 2, 0, 0. So it is 0. Just wait, please. We have to change this one. 286. We have changed R1, R2 is equals to, no, there is something. Just 1 minute, just give me 1 minute. Okay, R2 minus R1. I guess this one is R2 minus R1, 0, 1, R B equals to 0. Okay, so this one, it is right now. Okay, we have to put this operation. R2 is equals to R2 minus R1. So R2 will be equals to this minus this minus this one. Okay, so 2 minus 2 is equal to 0, 8 minus 6 is equals to 6 minus 6 is equal to 0, and 0 minus 1 is equals to minus 1, and 1 minus 0 is equal to 0, and 0, this will be equals to 1, and R3 will be equals to R3 minus R1. This minus then it will be equal to 0, 0, and it will be equals to R3 R1. This minus then it will be equals to it will be equals to what? 2 R3 and R3. It will be equals to 2, and this minus this is equal to minus 1, 0, 1. Okay, now, okay, let's start again. I was confused as well. Okay, so in our first step you will write the matrix A combined with identity matrix. What we do, we write matrix A 2, 6, 6, 2, 8, 6, 2, 6, 8, and combined with the identity matrix in here. Our main agenda is we have to make this matrix an identity matrix, and this matrix, and we don't care about this one. We don't care. Our main agenda is make this highlighted portion as identity matrix. To do so, we have to apply either column or the row matrix. Okay, to do so, we have to make column or the row operations we have to do. So our first thing, like whenever you do, it is a kind of trick. It is a trick. So always start from here, make it 0, make it 0, and this one. And this one, we have to make these elements 0, these elements 0, and these elements 2, 1. So we will always just, it is a trick that we start, okay, make this one 0 first. How you can make 0? So in my mind, I say if I make an operation like R2 will be equals to just changing R2 minus R1. If I do this thing, my R2 will be equals to R2 minus R1. This is R2. If I subtract this one, so 2 minus 2 is equals to 0. So whenever I apply operation, then I have to mention that on which column or row I have applied it. So I will say I applied it on R2, and R2 gonna be equals to R2 minus R1. Is it clear? R2 gonna be equals to R2 minus R1. So what I will do, 2 minus 2 is equal. I am not going to apply on R1. So R1 will be same. So R1 will be equals to 266100. So I will apply this operation now. R2 minus R1. R2 will be equals to 2 minus 2 is equal to 0. 8 minus 2, 6 is equals to 6 minus 6 is equal to 0. And then 0 minus 1 is equals to minus 1. 1 minus 0 is equal to 1. And 0 minus 0 is equal to 0. This one was my first operation. And then I have another operation. I would say R3 is equals to R3 minus R1, right? Because in my opinion, I saw when I make 2 minus 2, it will be equal to 0, which is my desired thing, right? So what I do again, I put the change the values of R3. 2 minus 2 is equal to 0. 6 minus 6 is equal to 0. 8 minus 6 is equal to 2. And then 0 minus 1 is equals to minus 1. 0, 0. 0 minus 0 is equal to 0. 1 minus 0 is equal to 1. Is it clear to everyone? Okay, I will repeat again so you will have more idea. So in Gauss-Jordan method, we will not take the adjoint or the determinant. We will have a different method. In a different method, what we're gonna do, we will combine your given matrix with the identity matrix. Okay, once you are given this thing, we talk about the three operations on the matrix. First operation was that you can interchange any two rows or any two columns. The second operation was that you can multiply a given row or a column with a non-zero element and add or subtract it from given column or the row. So you cannot do that you multiply a row with a matrix and subtract it from the column. No. If you apply a row matrix, then it should be in a row. Okay, is it clear? Either you have to apply row or you have to apply the column. Is it clear to everyone? Any question? Any question? Is it still confusing for you guys? Please let me know if it is confusing. Okay, I guess it is not confusing for you guys. Okay, so let's move on further. Okay, so can anyone tell me now we have the after the diagonal in the diagonal part, the below, it is 0. This is 0, 0, 0. Our next is that I want to make it 0 and make it 0 and make it 1, 1, 1. So what do you think how we can change? Any one of you can tell me that, okay, so now I want to either make it 0 or make it 1. This either make it 1 or either make this to either of this one with 0, 0. So what are we gonna do? So I will apply one another operation. In that operation, I would say that my R1 is be equals to R3 1 minus 3R2. And then R3 will be equals to 1 by 2. This is gonna be my second operation. So let's apply this one. My R1 gonna be equals to R1 minus 3R2. Okay, what is I multiplied this one with 3 and subtract it in here. So my my this one will be this one will be equals to 2. It will be 2 r1 minus it because it is 0, so it will be 2, and then it will multiply by it with 3, and then it will be 6. It will be then 0, and then it will be equals to 6, right? So there will be no change in R2, so it will be equal to 0 to 0, and in here it will be equals to 1 1 0 because there is no change in here, and there will be change 1 0 and 0, and finally I will multiply my R3 with 1 by 2. 1 by 2. If I apply this one with 1 by 2, then my answer will be 0 0 1. Sorry, it is 0, and it will be equals to 0 0, sorry, 0 0 1, and sorry, it will be 206 and 100 0 0 0 2 0 2 0. Sorry, wait, raise here. Okay, so let's try to write with the different. Okay, so our first operation was this one, and other operation we have after this one 206 100, then 0 2 0, and then after subtracting it will be -1 1 0, and finally you multiply this one, then 0 0 1, and in here -1 by 2 and 0 and 1 by 2. Okay, so this one gonna be the second operation, and then in the last one we will go with the another operation. That another operation will be r1 will be equals to r1 minus 6 r3 and r2 again multiply by this one. So if you're going to apply this one, so after applying this one, your answer will be equals to 2 0 0, and in here, sorry, it should be like dotted line anyway. So 2 0 0 and 7 minus 3, and then it will become 0 1 0, and this will be 0 0 1, and in here it will be equals to -1 by 2 1 by 2 0, and finally this one will be 7 minus 3 sorry 7 uh, 7 minus 3, and the last one will be 2 -1 by 2 -1 by 2 and 0 and 1 by 2 after this operation, and then again you will keep continuing this operation again and again, and in the final you will see it will become 1 0 0 0 1 0, and this one 0 0 1, and finally it will be equal to like 7 by 2 and -3 by 2 -3 by 2 1 by 2 1 by 2 0 -1 by 2 0 1 by 2. So this one will be your A inverse. R1 minus 3R3, yes. R1 minus 3R2. A21, second row. Okay, yeah. it is negative. So again, let's repeat it. So only the thing is you have to make this matrix, you have to make this matrix identity matrix. You can apply any row or column operation. In here I only applied the row operations. You can apply the column operations as well, but in here try to apply the row matrix, because in column matrix you gonna change this one with uh, with the identity matrix, so it will not work. So in this method, mostly in Gauss-Jordan method, we apply the row operations. Okay, is it clear to everyone? We will have some solved examples, and then after those solved examples, maybe you guys can feel better. Okay, oh, it's very long matrix. Okay, so in here, instead of this one, we will use R to find it. It will be really quick. We will not have any row operations or other stuff. We will just write a matrix and find the determinant over there. So for now, do you have any question? Okay, so if you guys don't have any question, let's move on to our R Studio now, and we will do the same things. We're gonna use the same thing in R. Okay, so now everyone, please try to open your R Studio. So I'm gonna open as well my R Studio. Okay. Wait, let me stop sharing. Share the screen.